Good afternoon to all present here. So myself Dr. Y. Shantaram, Associate Professor, Department of Civil Engineering. So today we are going to discuss about the topic on soil and foundation in the subject title of Foundation Engineering. So this picture clearly explains about that ground. So what do you mean by ground? So the ground comprises of soil and rock. So the globally the 70% of covers with water. Okay, this is an indispensable material, that is water and soil. So the only the 30% of globe is going to be covered with water and that is soil and rock. Okay, over that soil and rock we are going to make some construction activities. Okay, so this picture explains about that soil is common to all. So it shows that geologist, gemologist and agriculturist. So for all the sector the soil is a common material. So in that concern they will going to find out some extractions. For example, geologists they are going to study about the formation of rock and soil. If you go for the gemologist, this is a valuable gem present behind the ground surface. So we need a thorough knowledge of soil, then only we can explore the new minerals and new gems, that valuable gems present beneath the ground surface. So the main thing is agriculturist. So the agri people going to be yield some crops over the soil. So before that we have to get the thorough knowledge for the soil, then only we can go for the particular type of construction activities. So next comes to the final picture, the geotechnical engineering. So what do you mean by geotechnical engineering? So this is an engineering deals with study of soil mechanics. So after the study of soil mechanics, we are going to apply over for design of several foundation designs like that. So this is the response of geotechnical engineering. So starts from small hut to higher infrastructure, we are going to place this structure over the soil. Okay, so before that we have to get the thorough knowledge of engineering knowledge of that soil and rock before placing the foundation. It's a very important thing. This is the geotechnical engineering responsible. Okay, it may be either an high-rise infrastructure or a small hut. So these things going to be placed over the available ground surface only. The soil profile is not going to be maintained same in the place to place. It differs from place to place. So that is the problem here. So we have to get the thorough knowledge. Okay, say for example the x distance having an property of y, but whereas that if you go for the lateral distance of 1 meter or 1 feet, the soil property is going to be changed. So this is the problem in geotechnical concept. This slide shows that the major type of soil formation throughout the India. So alluvial soil, black cotton soil, lateritic soil, desert soil and marine deposits. So these are the different types of soil, major deposition of soil in the India. Okay, so what is the performance of soil? Okay, so the soil must be a good soil. So when we can designate the soil is going to be very good. So these are the following topics to be designated when the soil is become performance of soil is very good in nature. Okay. First is bearing capacity. What is bearing capacity? Okay, each and every soil having its own bearing capacity. So when you place the foundation, when you place the structure over the ground, it should possess some bearing capacity. So what is bearing capacity? So bearing capacity defined as the supporting power of soil or rock. Okay, that is called bearing capacity. So all the soil does not have the same bearing capacity. Okay, it possesses some very good bearing capacity for the structure. Provide firm support. So in case of any expansive soil, what happened? If you place the foundation, so what happened? It will get settled down. Okay, so big structure is to provide with a firm support. So that is very important thing. Okay, this depends upon your performance of soil. Third one, shear strength. Okay, like other materials, soil is having another engineering mechanics like the shear strength. It will fail by shear properties. Okay, but soil never fail with tension or compression. It always failing shear property only. Okay, shear is nothing but a slippage of soil particles. Okay, the shear strength characteristics of developed by two parameters. One is cohesion force and the another is called angle of shearing resistance. These two are very important property that club under your shear strength. Okay, next, least volume changes. It should not expansive one. Naturally, it should not be expansive one. It must be inert one. What happen if it be expansive? What happen? The volumetric changes will be in a major drawback for your placing of foundation. Okay, the foundation will be goes down if it having a larger amount of volume changes. You should be very careful about the It should be least volume changes. That means expansive. You should not place your foundation in the expansive, very large expansive soil. Rigidity, that is called no deformations. Like concrete, soil should have very good rigidity. Okay, when you are going to load over the soil or rock, it must possess some very good rigidity. Okay. Next one is permissible settlement. So unlike the foundation or the superstructure and substructure put together, it goes down. So definitely it will be goes down under the application of forces, because the building load is very huge in manner. Okay, when it starts servicing, what happened? The load will be a major drawback here. Automatically what happened? The foundation and then along with the structure, it got settled down. Okay, it should be a permissible limit. So it should not exceed the permissible limit. When the settlement is within the permissible limit, we are on the safer side. Okay. Next one is highly permeable. So the last one I noted that highly permeable. Okay. Soil must possess a highly permeable. So what happens if it happens a least permeable? So if the rainfall comes, what happens? The entire water will be stagnant on the soil. So it creates many problems. So environmental aspects also having many problems, and engineering aspects also we are having many problems. Okay, for breedings of mosquitoes like that. On the other hand, what happens that the moisture will be destroyed your structure. So automatically your bearing capacity will be goes down. Okay, it should possess the highly permeable. So that is nothing but it will allow the water immediately percolate inside the ground surface. Okay, that is called highly permeable. So these are the very good performance. The soil must be a good soil. So these topics should be covered. These are the main points to be designated when the soil has a very good soil. Okay. Weak soil. So what are the weak soil? Okay. So if you load over the soil, what happens? The structural failure will be happen. Okay. The structural failure means in the sense of either soil or structure. That concrete structure is going to be failed down. Okay. What happens if the structure immediately fails down? It leads to catastrophe. So catastrophe is a large disaster like that. Okay. So what happens? Catastrophe, it comes to an economic loss. Okay. And less safety. Okay. Once the soil is not in a strength or very good manner, these things will be happen. So we have to, as a design engineer, as a geotechnical engineer, or as a foundation designer, we should be look at very careful about that. The soil must be in very good. Okay, if the weak soil, we have to go for some of the improvement techniques, or else it will lead for the structural failure. With some of the pictures, glimpse of the pictures shows that the failure of soil. The first picture shows that the building is slided down. So because of the very poor soil. And the second picture, the big silos is plunged inside the ground surface. So due to the liquefaction effect. Okay, under the bridge you see that there is a differential settlement. So one side of that column in an upright position, and second column will be goes down. So it's a very dangerous one. If you not consider these settlement aspects and all, the differential settlement will be happen. And shear failure in soil. The last one, if you see the railway track and roads, it will be get warping. So this will happen. Okay, so why mechanics of soil? Okay, it's very important. So mechanics of soil is a branch. It deals with solid materials like soil will also deform under the exposed of forces. Okay, when the force is applied over the soil, what happen? There will be some changes. So there will be some behavior under the application of forces. That study of branch is called mechanics of soil, along with some hydraulic conductivity, because we cannot separate that soil and water. So always the soil and water is mingled together, so we cannot separate. Okay, once the rainfall comes, so the water is going to be finally destinated into your soil alone. So we cannot separate the water and soil. Okay, we have to study that under the application. When we have to study the force deformation or soil deformation under the application of forces, along with some hydraulic conductivity. So that is called the mechanics of soil. Okay, so Carl von Terzaghi, he is the father of soil mechanics. Okay, he is the pioneer in geotechnical field. He is the first person. He derived that the soil is an engineering material. So unless before that we don't know about the soil is an engineering material. So the Carl von Terzaghi is Austrian engineer. He first derives that the soil is a very good engineering material. So later the pioneers goes for that the award goes for father of soil mechanics. Okay, the field of soil mechanics. What is the application of field of soil mechanics? It's a tremendous one. The foundation design and constructions. So once you want to design a foundation and construction activity, we have to get that soil mechanics. Okay, we have to study that mechanics of soil. So pavement design, so road applications. We are having different types of road applications. we have to design the road based on your soil conditions. Underground structures, yes, obviously underground is nothing but interaction with your soil. Okay, earth retaining walls. So retaining wall is a structure used to retain the earth. Earth is nothing but soil. So design of embankments. So embankment is a major role in your placing your railway tracks and all. So highways and railway tracks, all the railway tracks are placed in the soil structure only. Design of earth dams and excavations. Excavation is a very important one. If you excavate the soil without knowing that mechanics or properties of soil, it leads to catastrophe. Okay, what happened? The excavated soil will be slips down. So automatically the soil will be fall on the persons. It leads to a larger catastrophe. Okay. So what is the application? What is the foundation engineering? The application of soil mechanics gives you a foundation engineering. The foundation is the bottommost region of any type of structure. So it is going to be transfer the load from superstructure to substructure. Okay, that is called foundation. For example, if you take the tree having shoot system and root system. Okay, so the root system is going to be take care of your shoot system. That root will be bounded with your soil. It will take care of your shoot system. So like that, the foundation is the bottommost region of your structure. It will take care of your loads and it will give the stability for the structure. Okay, that is the thing I have given here. Is the element of a structure which connects to the ground. So the function is, main function of the foundation is transfer the load from the superstructure to the substructure. In generally, the foundation can be classified into two different modes. One is shallow foundation, deep foundation. Okay. So the shallow foundation, what is the purpose of foundation? Before that we will discuss the purpose of foundation. Okay. So distribute the weight over the structure to provide the level surface of construction, to prevent the lateral movements of the supported structure. Okay. So next class we will discuss about that classification of foundation. Thank you.